This problem is about charging a capacitor, and you need to find out what is the voltage across the capacitor after the certain time. So let me explain this problem. So you have an uncharged capacitor. So this is the symbol for the capacitor. You draw the two parallel lines, and we call the C, and then it is connected with another resistor R, and then you have a supply voltage, and this is the battery. All right. We call this EMF, or the applied potential, and this is in the VC is the potential across the capacitor, and it says you have to find out what is the voltage across the capacitor after 11 milliseconds. So the formula, in order to calculate this one, so the potential across the capacitor at any point in time can be given by this formula. This is the formula, and this gives you the potential or the voltage across the capacitor at any time t. Okay, and RC is called the time constant. So let's find out what is the value of RC. The value of resistance is 23 kilo ohm. 23 kilo ohm. Kilo ohm is 10 times 10 to the 3. And the capacitor is 1 microfarad. 1 microfarad is 10 to the negative 6. If you do the math, what you get is RC is equal to 23 times 10 to the negative 3 second. And this is equal to 23 millisecond. I'm just plugging this value into this equation now. Alright? So the VC, which is the voltage across the capacitor, and this epsilon is the applied to the potential. It's the battery, the supply voltage, and we're assuming there is no any internal resistance. That's why it is called ideal. The 7 volt. This EMF value is 7 volt. 1 minus e to the minus t. The time is asking you, the time is given 11 milliseconds. So just putting the 11, and RC is 23. And remember, I've made this the both units, this time and this time has the same unit, the millisecond and millisecond. Okay, and if you do the math, the number you will get is VC. You will get is this 2.7 volt. 2.7 volt. That's the answer. Okay, you just have to use the calculator. That's it.